Welcome to part 5 of deploying Kubernetes-based distributed systems. This part will follow the deployment of workloads for the key-value storage system example. Deployment parameters will define how components communicate inside and across clusters. Such topology needs to optimize communication to remain inside the clusters. The workload YAML file contains a series of kubectl, Helm, and PowerShell commands. Kubernetes commands may take time to bring a cluster to the desired state. Artifacts also can be managed by different methods affecting behavior. Creating the Iron RSLKV cluster demands creating service certificates. Such certificates will have information about the IP addresses of all members. That means the cluster initialization needs to wait until the certificates are copied to the pods. A design pattern for such initialization demand is starting containers and waiting for a signal. Besides new clusters, it is critical to test workloads deployment to an existing cluster. Namespaces are a mechanism to isolate the system modules while grouping related resources. The workloads file starts deleting namespaces, which also removes the linked artifacts. The example then uses Helm to deploy a chart for the replication components. Helm will drive the download of images and their initialization in the clusters. For clusters to retrieve images from a registry, authentication is done by a secret key. For a local host, pods start and their internal IP addresses within the cluster are used. For a cloud deployment, public IPs known after resource creation are used instead. Both for local host and cloud deployments, the ingress component is then configured. Cloud providers will have a system-specific load balancer, at times automatically installed. For a local host deployment, some bare metal solution should be used instead. When all pods are ready, browse to the endpoints and test setting and getting values. Tracing information will be helpful for the following video about debugging processes and tools. This concludes part 5 of 6 of deploying Kubernetes-based distributed systems, circa 2022.